Right. What we want to do now is to learn how to retrieve from the database using select. So the basic form is select star. Star means anything, all the column names, where, however many there are in the table. So if you have 200 column names, then select all of them. So select all the column names from the table and how many rows? Automatically by default, all the rows. All right, all the rows. If you have 5,000 rows, all the 5,000 rows, the 200 columns will be retrieved. So select star from table. Now, although this is, it gives us an impression of a humongous table, this is quite commonly used because when we want to, we are not very sure about the table, we were being handed the table first time, we tend to want to have a peep, and that is how we do it. Okay. You can always expand from this basic syntax further. All right, so if we just do this on customer table, replace the table with customer, we get the whole table. This is what we get. This is what is on the left hand side is what's in the database. The right hand side is what we get as a result, or in Python later on we'll see. Uh, but the entire table is being returned. If the table is super large or having many columns or many rows, we need to filter. We need to filter. The way we do it is select the columns, column 1, column 2, column 3 from the intended table. We can also have multiple table selection with table 1, table 2, table 3. Right, we can do that. Um, and sort of select from this column of table 1 and that column of table 2 and yet another column of table 3 and stick them together as a returned result. So we can do that from multiple columns, again, comma separated tables, where condition on which rows to select from are being specified here. So it tends to be like name equals to A% and address equals to B%, and postal code equals to whatever. So we can do all the and this and that, or this and that, or so the using the and or, we can combine to make the condition a true value, and those rules that satisfy a true value will be selected. Additional, so the square bracket here are those are just specifiers. You don't type them into the SQL statement. Uh, they indicate optional additional modifications of the statement. So if we put in order by, that means it's a sorting. So when you retrieve all the rows, they're going to be sorted, but based on which column? So you need to specify order by what condition or what criteria, right? Order by what? And this criteria here can involve columns that are invisible. That means the columns that didn't get selected in the select columns. So you can sort it by some other columns present in the tables, but didn't get retrieved. Obviously, it will look a little bit mysterious why the rows are appearing the way they look. All I'm saying is this criteria is not dependent on what columns you select, but certainly dependent on what columns exist in all the tables. And it's frequently useful to put in a limit. So if you limit 5, then you only see 5 rows. If you don't order by and you just use limit, then any random 5 rows will be shown. So don't take your luck on those. You need to sort first. Then when you limit, for example, you sort by ascending age. Then when you limit 5, the top 5 obviously, it's going to be the youngest 5 people on the database. If you want to do some sort of a web paging, page 1, page 2, page 3, right? What is commonly used is to say limit 5 rows in count, but after sorting by age, let's say you limit by 5 rows, the first page is just that. Second page is offset 5. That means it's going to be from 6 to 10. The third page is offset 10 to 11 to 15. So this is how we can do paging, segmenting of the rows that are supposed to be retrieved in whole bulk, but we can then sort of process it segment by segment. All right, so pretty powerful modifications are allowed in this setup, in this select statement. like this. So let's have a try in our database. Now we earlier on deleted everything from the customer table. So we need to get back our customer table. Where's our table builder? All right, over here. So we're going to build 4 rows with the Peter as well. And let's have a refresh. Great. Now we have that. And we are ready to sort of look at or try out our select statement. Let me just copy from my slide. Okay. And let's erase the delete. Dangerous. So select ID and name from customer. Well, I can keep it in separate lines, and it's nice to indent, additional modifications of the statement in the new line, second, third, fourth, fifth lines with indentation to make it seem visually related to the first statement. So when name contains little a, okay, who contains the name little a? Kate, yes. Mary, yes. Right. So name contains little a, and sorted by name. So so Kate will come before Mary, not because its ID is smaller, right? But then we say order by name descending, descending. So now it's going to sort in reverse. Mary will come first before Kate in our end result. In the database, we have no control, all right, over whether Kate is stored before Mary or after Mary. That's the beauty of it. How it is being stored is best managed by the SQL server, who knows about the hard disk and the partitioning and whatnot it is. All right, it's not our desire to know about all those nitty-gritty storage details that don't affect our business communication here. So what we want is to retrieve in a sorted manner in reverse. So let's try it out. Okay, so indeed we get back Mary and Kate this way. Now you can always think about just not sorting, not sorting, just get back the whole thing and then let our Python program sort it. So that's fine too, depending on the situation. It's whether the server does the job or your program does the job. Um, by no means there's a fixed answer to it because it also depends on the network delay, server's load, various considerations. So perhaps as a first attempt to write your program's logic, it's good to just get it working first. Yeah, so whatever that works, get it working first, then fine tune the performance. Okay, good. Now, since we are talking about select, let's look at what select does. The result of the select is looking like a table, and actually it's a table. So if it looks like a table, what if we want to further process this table? As in, we would like to select something else from this table, because there are cases where a single select is unable to perform the desired outcome that is only achievable by select first, then select from this result more selects, another select. Yeah, so this chained select will produce an outcome that is not achievable by compressing the logic into a single select. It's not possible. So what should we do? One easy way is to think of, can we store the outcome of the select as a table, like create a temp table, select and store into it, then we select from that temp table and then delete that temp table.